Okay, so here is your lecture for 5.2. So this section, I will tell you, we're not doing a whole lot with it just because it's important, but it's not like as critical as some of the other stuff that we need to still cover left in these in the book. So 5.2 is proving trigonometric identities. So you remember we got a bunch of identities in the last section, and you also had a bunch that you should have learned in Algebra 2, although most of them are repeats in your book in 5.1. So we're going to actually look at kind of proving that, sort of, kind of, whatever. Okay, so I will tell you we're not obviously doing a ton of these problems, but stuff like 5 through 10 and like 11 through 51, we're doing some of, but not a lot of it. I'm just picking a few problems, so you only have about 6 problems from this section that you actually are required to be able to do. So we're just going to start out with number 6. These ones say to tell whether or not f of x is equal to sine of x is an identity. So essentially, with whatever we're given, we're going to basically prove that it's equal to sine of x. So number 6. F of x is equal to tangent of x over secant of x. So now, let's think through kind of what I need to do to simplify this down, because essentially all we're doing is simplifying. We're showing that it's equal to sine of x or that it's not equal to sine of x. So how could I simplify this? Well, I know I have a fraction, so I'm going to split the fraction up into more fractions, because I know that tangent is sine over cosine, and I know that secant is 1 over cosine. So I'm going to rewrite it that way. So this becomes sine of x over cosine of x all over 1 over the cosine of x. So now it's like, okay, well now I almost just made it look more complicated because I have 2 fractions, but when I'm dividing by a fraction, I multiply by its reciprocal. So this is really the same thing as sine of x over cosine of x times cosine of x over 1. Okay? And I don't necessarily need the over 1, but just so that we see exactly what's going on. Cosines cancel, leaving me with sine of x. And so then, yes, it is an identity. Okay, so tangent of x over secant of x is in fact equal to sine of x. So the next section of stuff says to prove the identity. Well, when we're doing that, there's an important rule that we have to follow. So prove the identity. Okay, when doing problems like this, it's very important to realize that if we're proving something, we can only change one side. So we can only change one side of the equation. Okay, the book says basically LHS for left-hand side, or RHS for right-hand side. Okay, so those are your 2 options. Okay, with this particular section, you can pick either side that you want to do. I most commonly do the left-hand side one. That's just kind of the one that I usually end up doing, and I leave the right side alone, but it's pretty much up to you, honestly, which one you want to do. So let's start with 12. So 12 we have sine of x times cotangent of x plus cosine of x tangent of x is equal to cosine of x plus sine squared of x. So let's look at it and let's just think about some of the possibilities that we would have here with this problem and what we could do. So I'm going to leave the right-hand side alone, okay? I'm going to deal with the left-hand side. So let's think about what we have here. Now, I could go ahead and rewrite this stuff here. I could go ahead and rewrite this here. Okay, that's one option. I could go ahead and rewrite this stuff, and then I could distribute. I could distribute first, and then I could rewrite stuff. So it's purely up to what you want to do. I think I'm going to distribute first and then rewrite stuff. So, and the left side, the way I do this is I just bring the left side down. So I just draw an arrow, or sorry, the right side. I just bring the right side down and I do stuff to the left side. So, I end up with sine of x times cotangent of x plus sine of x, cosine of x, tangent of x. Okay, and all that stuff's being multiplied is equal to everything that's being brought down. Okay, so now I can rewrite cotangent of x as cosine over sine. Okay, that's an identity that we did in 5.1. So sine of x times cosine of x over sine of x. Plus, I have sine of x times cosine of x times tangent of x is sine of x over cosine of x. And all that's equal to everything over there. So now I can go through and I can cancel stuff out. So I can cancel these two signs here because they're top and bottom. So they go away. Now over here, I have a cosine top and bottom, and I have two sines on the top, so I can't do anything with sine, but I can cancel out these cosines. So cosines go away, leaving me with cosine of x over here, plus sine times sine is sine squared, which is equal to cosine x plus sine squared x. So I've proven it. And I need to put a check there to show that I've actually proven it. Okay? Now, let's look at number 16. So with this one, it's a little different. Okay, we have tangent of x plus secant of x is equal to cosine of x over 1 minus sine of x. Okay, so again, I need to prove that this left side is equal to the right side. So, I am just going to bring everything on the right-hand side down. So, bringing that down. Now, over here, what I would recommend doing is rewriting these things. So, I would rewrite tangent as sine of x over cosine of x. Plus, now I have secant of x. So this is 1 over cosine of x is equal to what I'm bringing down. Now, this gives me a common denominator, so I can write it all as one fraction. And I'm going to flip it and write it as 1 plus sine of x just for the sake of the rest of the problem, because it really doesn't matter since they're being added. So 1 plus sine of x over cosine of x is equal to all that stuff. Now, what I want to do here, if you look at these kind of look like opposites with just the sign being different. So what I'm going to do is I'm going to multiply this over here by 1 minus sine of x over 1 minus sine of x, okay? I'm not moving this one over, okay, that's really important. I'm just multiplying this to try to simplify some stuff down, okay? So, I'm going to multiply by 1 minus sine x over 1 minus sine x. Now, what does that leave me with? Well, hopefully you recognize that as a difference of squares, which gives me 1 minus sine squared of x on top, and on the bottom, that gives me, I'm just going to leave it separated, so that gives me cosine of x times 1 minus sine of x. Okay, now, with this, okay, what I need to think about is that 1 minus sine of x. Now, remember back to our identities that we had. Okay, we had the Pythagorean identities that said sine squared of x plus cosine squared of x is equal to 1. So 1 minus sine of x could be written as cosine squared. So I could rewrite the top as cosine squared of x over cosine x times 1 minus sine x. Now, this is why I didn't want to go ahead and multiply the bottom through, in case you were wondering. This right here is why. Okay, the squared part goes away and the cosine goes away. Okay, leaving me with now cosine of x over 1 minus sine of x, which is equal to what I brought down, cosine of x over 1 minus sine of x. And those end up being equal, so I've proven that it's true. And I'm trying to just give you guys the easier ones of these to do, okay? I'm not trying to kill you with them or anything. So we have one more to do. So that is going to be number 22. So this one is going to look a little different. 22. Sine squared alpha, fish, whatever you guys like to call it. Cosine squared alpha is equal to 1 minus 2 cosine squared alpha. Bring it down a little bit. Okay, so with this one, what we have here is what looks like a Pythagorean identity, but it's really not, because this sign right here is negative. If this was positive, that would just be 1, and then this wouldn't be true. Okay, so we need to look at this, and we need to evaluate, how could I rewrite this stuff? Well, at this point, obviously we have a couple options because of our identity, okay, which we wrote before. So that identity that we know is that sine squared plus cosine squared is equal to 1. Well, I could easily rewrite the sine squared as 1 minus cosine, but I could also rewrite cosine squared as 1 minus sine. So this is where I have to pay attention to the right side and figure out what I need. Okay, so I need to be left with cosine, so I probably should rewrite sine in terms of cosine. Okay, so that's my thought process for this one. So I'm going to rewrite sine in terms of cosine as 1 minus cosine squared. So I'm rewriting sine squared as 1 minus cosine squared of alpha. It just froze, sorry about that. Minus cosine squared alpha. And that's equal to, I'm just going to keep bringing this stuff down. Now, I have 1, and then I have 2 negative cosine squared alphas. So 1 minus 2 cosine squared alpha is equal to 1 minus 2 cosine squared alpha. And that is true. Okay, so that kind of stuff is all you're responsible to be able to do. So that being said, from this section, okay, your only homework problems are 5, 7, 11, 19, and 21. Okay, and please remember, these are due next Sunday night. Okay, this coming Sunday night, the 29th at midnight. And if you haven't turned in your other homework, please make sure you do so.